Hi friends, in this video we are going to discuss the syllabus which has been included in the cryptography and network security. The subject code is PCS 703. The CIE marks will be 50 and the external SEE marks will be 50. So in this cryptography and the network security, some of the basic concepts which are included for securing our data through the network. So we can use any one of the teaching method. Either we are going to use the chalk and board, or maybe presentation, or maybe video, or maybe group learning, or maybe problem based learning, or we can introduce some of the case studies. Any one of the method we can use under the cryptography and network security. In the model 1 we are going to discuss some basic concepts of model for network security, classical encryption techniques. We will use several encryption and decryption techniques for different problems, or we can say it as the methods. Out of that we will use a symmetric cipher model, substitution cipher, Caesar cipher, monoalphabetic cipher, Playfair cipher, Hill cipher, polyalphabetic ciphers, one-time pad, steganography. So these are some of the problems we will be discussing with respect to these techniques. The block cipher and then data encryption standards, traditional block cipher structures, data encryption standard. As an example, we are going to discussing what are the strength of DS, block cipher design and principles. So after each and every module, they have included or indicating some of the major highlights of a textbook. Within that, we are going to discussing on the chapter 1.8. 3.1, 3.2, 3.5, 4.1, 4.2, 4.3, 4.4, 4.5. With respect to the understanding purpose, we can refer any textbook or maybe any YouTube material or any material which may be helpful for you. It is very good. But the important thing is that with respect to the SEE component point of view, we need to refer onto the prescribed textbook only. So they will clearly mention which are all the chapters we need to refer for external examinations, or the syllabus it has been included in the subject. So always we need to refer under the prescribed textbook to get the good marks in the examination. So likewise the module 2, which is going to deals with respect to the pseudo random numbers generators, linear congruent generators, Blum-Blum-Shum generator. So these are the two techniques we are going to use, the pseudo random number techniques. Public key cryptography and RSA, principles of public key crypto system, public key crypto systems, applications of public key crypto systems, requirements for public key crypto system, public key crypto analysis, RSA algorithm, description of the algorithm, computation aspects, the security of RSA. So in this we are going to discuss what and all the major advantages, disadvantages, strength of RSA algorithm. So as we know that public key cryptographic technique will use the RSA algorithm. So we will consider one simple example. From that we are going to how to perform the encryption and decryption. So similarly we are going to discussing under the Diffie-Hellman key exchange algorithms, key exchange protocols, man in the middle attack, elliptic curve cryptography, analog of Diffie-Hellman key exchange, elliptic curve encryption, decryption, security of elliptic curve cryptography. So similarly, module 1, module 2 also, which has going to including under the textbook 1, chapter 8.2, 9.1, 9.2, chapter 10.1 and 10.4. So when it comes to the module 3, we are going to discussing on the applications of cryptographic hash functions. So two simple hash functions, key management and distributions. Symmetric key distribution using symmetric key encryption, symmetric distribution using asymmetric key encryption, distribution of public keys, X.509 certificates, public key infrastructures, or we can indicate as PKI infrastructures. So 11.1, 11.2, 14.1, 14.2, 14.3, 14.4, 14.5, which are the syllabus which is included under the module 3. When it comes to the module 4, user authentication, remote user authentication principles, Kerberos, remote user authentication using asymmetric encryption, web security consideration, transport layer security, email threats and comprehensive emails security, SMIME, pretty good privacy, shortly known as PGP. So similarly 15.1, 15.3, 15.4, 17.1, 17.2, 19.3, 19.4, 19.5. So these are the components which will include in the module 4. So the last module, domain key identified mail, IP security overview, IP security policy, encapsulating security payload, combining security association, in-thread key exchange. So the chapters which will include in 19.9, 20.1, 20.2, 20.3, 20.4 and 20.5. So some of the concept which may comes or may not comes under the corresponding the models. So for that reason always we need to refer for a prescribed textbook to score a good marks in the examination. So once upon we have completed all the 5 models, what and all the students will learn, or we can say it as students will able to analyze, or we can say it as what and all the course outcomes we are going to generate it. The first course outcome will be the explain the basic concept of cryptography and security aspects. So what are the basic concepts? Cryptography. So encryption is nothing but what, decryption is nothing but what, and security aspects which has been involved in the subject. And then apply the different cryptographic algorithms for different applications. So we'll study the several cryptographic algorithms within that RSA or maybe DFL1 or maybe some of the substitution techniques. So we are going to apply the different cryptographic algorithms for different application for a better way. Analyze the different methods for authentication and access control. Within that we already know that CIA triangle, confidentiality, integrity and authenticity. So that we are going to analyzing by making use of several methods. Describe key management, key distribution and certificates. And the last course outcome will be the explain about the email and IP security. So these are the course outcomes the students able to learn after the completion of all the 5 modules. Thank you.